Hello everyone, welcome back to the another session in Design and Analysis of Algorithms. The topic name is Graph Traversals, BFS and DFS. This topic you will find in 4th unit as topic number 1. Now, let's talk about what is graph traversal. A traversal is a systematic procedure for exploring a graph by examining all of its vertices and edges. A traversal is efficient if it visits all the vertices and edges in a linear time. So basically we do have two kind of traversal techniques. The two traversal methods described are breadth first search and depth first search. Now we'll discuss about breadth first and depth first. Before we discuss about this two techniques, we'll talk about the advantage of these two techniques. So you can find out the connected components and spanning trees using of these two traversal technique. Let us assume that G is a connected undirected graph. Now take this example. G is a connected undirected graph. Then all vertices V, V1 and V2 of G will get visited on the first call of BFS. If G is not connected, then at least two calls to BFS will be needed. Hence, BFS can be used to determine whether G is connected or not. All newly visited vertices on a call to BFS from BFT represent the vertices is a connected component of G. Hence, the connected components of graph can be obtained using BFT. As a final application of BFS or DFS, in the problem of obtaining a spanning tree for an undirected graph G, the graph G has a spanning tree if and only if G is a connected. Hence, BFS and DFS determines the existence of spanning tree. Spanning trees are obtained using BFS or DFS or called breadth first search or depth first spanning trees. Now we'll discuss about even that spanning trees, how you can get from a connected graph, connected undirected graph, how we will be getting spanning trees using this BFS and DFS. So before we see that, we'll take some algorithm and we'll see how the visited will get vertices will get visited. Now, so this algorithm is of BFS. Algorithm BFS. This BFS to visit all the vertices and the edges in the connected graph. A breadth first search of G is carried out beginning at vertex V. For any node I, visited I is equal to 1. If I has already been visited, now I'll give small example and we'll trace this algorithm. Yes, I know that you don't have any lab implementation part, but if you can trace this one through an example, I believe that you will be strong enough to understand the concept what I am teaching. Now, so in the previous slide, we explained you about G should be a connected graph. Correct? Now it is a connected graph and it should be undirected connected graph. Yes, it is an undirected connected graph. So what exactly we'll be going to do is, we'll be going to visit the vertices, all the vertices and the edges. Now, so when I visit the vertex, let us assume that I wanted to visit the first vertex. Then that vertex will be stored into one array. Okay, visited of V is equal to 1. So if I has already been visited, that means I'm just making this change. I'm just keeping this V into I. Okay. Now, if I is already visited or if V is already visited, then the graph G and array visited are global. Visited array is initially it is 0, and when you start visiting each vertex, will add the vertices into this array. Finally, your array is going to have whatever vertices you visited, in which order you visited, that is going to be available in this array. Now, let's trace this algorithm with the sample example. So initially we'll be taking u is equal to v and visited v is equal to 1. So we will repeat this for all vertices. W adjacent from u do. If visited w is 0, then add w to q. So what is here w? W is the unexplored vertex. What do you mean by unexplored vertex or explored vertex? Explored vertex in the sense, when you visit some node, we will be going to explore the possible edges which are from this node. As far as breadth first search is concerned, we will be going to find out the vertex which is being visited and will be finding out the possible edges. That means 1 is visited and possible edges of 1 is what? 2 and 3. So we'll visit second vertex and also we'll visit third vertex. So W is what? Unexplored vertex. So we'll add W to Q, unexplored vertex to the Q when W is 0. Fine. Now visited W is equal to 1. Then if Q is empty, then return. Now that means what? When Q is empty, then return means no explored vertex. Now delete the next element U from Q, get first unexplored vertex, and this will repeat till the condition get fails. So we'll see some example and we'll come to know how spanning tree will get generated from the graph. Now, so this BFS is going to use the data structure which is Q. Now let's see how we'll visit the vertex and how we will store into the queue. So I'm at the first vertex. As far as the algorithm is concerned, we'll be going to first of all visit the first vertex, right? So that means the first vertex is going to be get placed into your queue. Fine. That means 1 will be inside of queue. So in the first, before of this slide, that means algorithm, I told you that you have to visit the vertex and also you have to visit the exploration of this vertex. What is exploration? Finding the edges, availability of edges from this vertices. So what are availability of edges from this vertex? 2 and 3. 1, 2, 2, 1, 2, 3. So now we will be going to visit 2, 3. Part of these are exploration of one vertex. That means I am going to place 1, 2, 3 that I visited. And as far as BFS is concerned, we'll be going to visit the vertices breadth-wise. Now, so add a vertex into the queue and mark it we visited. Now, add the adjacent vertices of the vertex in queue that are unvisited. Remove the vertex from queue if all the adjacent vertices have been visited. So we will be going to remove this one from the queue. That means DQ1. Why I'm deleting this or why I'm performing DQ operation? Because I visited all the edges of this one, or else all the vertices which are explored from vertex 1. That's what one is DQ from the queue. Now update your queue. Your queue is having what? 2 and 3. So now this is your next vertex. What has to be get explored? So when you come to 2, you will be having the exploration of this 2 vertex. That means 4 and 5. Correct? Now update your queue value. NQ 4, 5 vertices and mark these 2 vertices we were visited. Now, which is completed? Which vertex exploration is completed? 2 exploration is completed. Now you have to perform DQ of 2. Perfect. Now, so update your queue with the values which are having 3, 4, 5. Now again what you have to do? You have to find it out. The next vertex which is 3. Now go to 3. What are the exploration of this 3? Which is 6, 7. Now store into your queue. So once after you did the exploration of third vertex, delete it. DQ from queue. So if you do so, finally you will be DQ 4, 5, 6, 7, 8. Since all the vertices have been visited, finally your queue will be empty. So until your queue is empty, you have to repeat this thing. So The final BFS traversal is what? 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. So this is what final BFS traversal for this graph. Now the spanning tree is what? This. The spanning tree for this graph using BFS traversal technique is what? Right? Now we'll see even for DFS how we will do. So DFS will use stack. So whichever vertex we visited, that vertex simply it is going to be get placed in the stack. So once after you visited this vertex, we will be going to visit till the depth. So after you complete the first vertex to till the last node, the leaf node, you will be going to store all the elements into this. Fine. Now we'll see how it works, the algorithm. Now, so this is the example which is connected graph again. Now I am taking some stack. So what I told you that you have to visit the first vertex. As soon as you visited, you mark this visited vertex into your stack. So that I visited 1. And again, you need not to explore the vertex which you visited. You have to go to the till the leaf node. Correct? Now, so 1 to 2 and 2 to 4, 4 to 8. This is depth first search. So till the depth you have to finish it off. That means 1, 2, 4, 8 and up to 8 we will come, right? So once after you finish this, that visiting of vertices we are marking by keeping into the stack. Once after you did this one, vertex 5 is searched for adjacent unvisited vertices. If no unvisited vertices found for the 5, then pop 5 from the stack. There is no unvisited vertex, right? We were visited. Now let's see. The top of the stack is 5. So this 5 edges are what? 8 and 2. So we visited 2 and 8. There is no unvisited vertex of this 5. Then we will pop this 5 from the stack. Now, after you pop 5 from the stack and look for the unvisited vertices of the top of the stack. So, what is the top of the stack? If you delete this one, 8 is the top of the stack. Now, again find out the unvisited vertex from the 8. So, which are unvisited from 8? 8 is your visited vertex and it is top of the stack, and you have to find it out the vertex from this. So, that means 6, 3 and 7. So your stack is going to be updated with the values of 1, 2, 4, 8 and 8 is what? 6, 3 and 7. Perfect. Now again, once you found unvisited vertex, the last top of the stack is what? 7. I'll write a little bit clearly. 1, 2, 4, 8, 6, 3, 7. Now this is your stack. Now which is the top of the stack? 7. So whichever is this top of the stack, you have to make sure that you visited all the vertices of this 7. Now let's check. 7 is having availability edges are with 3 and 8. That's it. So you visited 3 and 8. You need not to visit any other vertex as you don't have any other. Whichever is having, we already visited. So pop 7 from the stack. Pop 7 from the stack and look for the unvisited vertices. If no vertices found, pop the next element and search. Keep doing until the stack is empty. So finally, you will be making stack is empty because all the vertices are visited and there is no vertex which is unvisited. Now the DFS traversal is what? 1, 2, 4, 8, 5, 6, 3, 7. This is the DFS traversal. Now the spanning tree for this traversal is this is what your spanning tree. So point is, when you wanted to consider a graph to get spanning tree, you can use BFS traversal technique and DFS traversal technique. So this is about graph traversal techniques. Thank you all.